A space telescope is a type of astronomical instrument designed to observe celestial objects from space, beyond the interference of Earth's atmosphere. Unlike traditional ground-based telescopes, which must deal with atmospheric distortion and light pollution, space telescopes operate in a vacuum, providing clearer, more detailed images of distant stars, galaxies, planets, and other astronomical objects. These instruments collect electromagnetic radiation, such as visible light, infrared, ultraviolet, and even X-rays and gamma rays, from distant regions of the universe. The primary advantage of a space telescope is that it can observe in wavelengths that would be absorbed or scattered by Earth's atmosphere. For example, ultraviolet and X-ray radiation from distant stars and galaxies do not reach Earth's surface, making it impossible for ground-based telescopes to detect these wavelengths. Space telescopes, therefore, enable scientists to observe parts of the electromagnetic spectrum that would otherwise be hidden. The concept of a space-based telescope can be traced back to the early 20th century, when astronomers began to theorize that observing from space could offer new insights into the universe. The first official attempt to build a space telescope came in the 1940s, when scientists envisioned using satellites for astronomical observations. However, it wasn't until the 1960s that space-based telescopes became a reality. In 1962, the X-ray telescope was launched aboard the Explorer 11 satellite, marking the first successful use of a space telescope. This satellite observed X-rays from the Sun and other celestial objects, opening the door for further space-based astronomy. The true milestone in space telescope history came in 1990 with the launch of the Hubble Space Telescope. Hubble provided a new level of detail and precision, allowing scientists to capture images of distant galaxies, nebulae, and stars in unprecedented detail. Hubble has since become one of the most iconic space telescopes and continues to contribute to astronomy. Space telescopes are crucial for advancing our understanding of the universe for several reasons. First, Earth's atmosphere distorts and absorbs certain wavelengths of light, which limits the effectiveness of ground-based telescopes. Space telescopes are not affected by this interference, allowing them to observe clearer and more accurate images. Second, without atmospheric distortion, space telescopes can produce images with far greater resolution than ground-based telescopes. This enables astronomers to study objects that are much farther away with greater clarity. Third, space telescopes can observe a wide range of wavelengths, including those that are blocked by Earth's atmosphere, such as ultraviolet, infrared, and X-ray radiation. This helps to uncover hidden aspects of the universe, such as the internal workings of stars, the formation of galaxies, and the detection of dark matter and energy. Space telescopes come in various forms, each designed to observe specific wavelengths of light. Here are the most common types. Optical telescopes are designed to capture visible light, just like the human eye. The Hubble Space Telescope is a prime example of an optical telescope in space. By observing visible wavelengths, it has provided some of the most iconic images of galaxies, nebulae, and planets. Infrared telescopes observe in the infrared spectrum, which is useful for studying cooler objects in space, such as distant stars and galaxies that are hidden by dust. Infrared telescopes, such as the James Webb Space Telescope, offer insight into the early universe and the formation of stars and planetary systems. X-ray and gamma-ray telescopes observe high-energy radiation emitted by hot, violent processes in space, such as the remnants of supernova, black holes, and neutron stars. Instruments like the Chandra X-ray Observatory allow astronomers to study the most extreme environments in the universe. Radio telescopes detect radio waves emitted by celestial objects. They are especially useful for studying phenomena like pulsars, quasars, and the cosmic microwave background. A famous example is the Very Large Array, a ground-based radio telescope network, though space-based radio telescopes are also in development. The Hubble Space Telescope, launched in 1990, is perhaps the most well-known and successful space telescope to date. It has revolutionized our understanding of the universe, providing deep insights into the structure and evolution of galaxies, the life cycle of stars, and the mysteries of dark matter and dark energy. One of Hubble's most significant contributions has been its ability to accurately measure the rate at which the universe is expanding. By observing distant supernovae, Hubble helped determine that the universe is not only expanding, but that this expansion is accelerating, a discovery that led to the theory of dark energy. Hubble's high-resolution images of distant galaxies and nebulae have also provided stunning visual records of the universe's most beautiful and mysterious objects. Some of Hubble's famous images include the Pillars of Creation in the Eagle Nebula and the Hubble Deep Field, which captured thousands of galaxies in a small patch of the sky. The James Webb Space Telescope, JWST, launched in December 2021, is the successor to the Hubble Space Telescope. JWST is designed to observe the universe in the infrared part of the electromagnetic spectrum, which allows it to peer through cosmic dust and observe the formation of stars and galaxies in unprecedented detail. JWST's larger mirror, about 6.5 meters in diameter, compared to Hubble's 2.4-meter mirror, allows it to gather more light and observe farther into the universe. Its position in space, orbiting the second Lagrange point, L2, allows it to avoid interference from Earth and the Moon, providing a stable environment for its infrared observations. One of JWST's primary missions is to explore the early universe by observing the formation of the first galaxies, stars, and planetary systems. This mission will help scientists understand how the universe evolved from the Big Bang to the galaxies we see today. Developing and deploying space telescopes come with numerous challenges. Sending a telescope into space requires overcoming significant technical and logistical hurdles. Telescopes must be launched into space aboard rockets, which is expensive and requires precise deployment mechanisms. After launch, space telescopes must unfold and position themselves correctly in space, which can be a complex process. Space telescopes rely on solar panels for power, and maintaining communication with Earth requires sophisticated technology. The vast distances involved mean that communication delays and bandwidth limitations must be carefully managed. The mirrors used in space telescopes must be of exceptional quality to collect and focus light from distant objects. They must also be lightweight and able to withstand extreme temperatures. Many telescopes use segmented mirrors that unfold after launch, such as the JWST's mirror. Some telescopes, particularly infrared ones, must be kept at extremely low temperatures to avoid interference from their own heat. Advanced cooling systems like those used in the JWST are critical to their success. The future of space telescopes holds exciting possibilities. Upcoming missions, such as the Nancy Grace Roman Space Telescope, are designed to study dark energy, exoplanets, and the structure of the universe. Other missions are exploring the idea of small, cost-effective telescopes that could be deployed in constellations to study the universe in a more diverse way. Additionally, future technologies may allow space telescopes to be deployed around other planets or even asteroids. This would provide even greater precision in studying cosmic phenomena from new vantage points. Space telescopes have been essential in making groundbreaking discoveries. Space telescopes have played a key role in discovering exoplanets, many of which could be potentially habitable. By observing galaxies at different stages of their evolution, space telescopes have helped scientists trace the history of the universe. Space telescopes have provided invaluable data on the properties of black holes and their influence on their surroundings. Observations from space telescopes have helped scientists investigate the mysterious components of the universe, such as dark matter and dark energy. Space telescopes represent one of humanity's greatest achievements in the quest for knowledge. By enabling astronomers to observe the universe from outside Earth's atmosphere, space telescopes have opened new frontiers in astronomy, providing insights that were once thought impossible. As technology continues to advance, space telescopes will undoubtedly continue to play a central role in uncovering the mysteries of the cosmos, shaping the future of space exploration.